Hi, I'm Jeff Shoup, and we're getting down to the brass tacks and hard facts of a 2-inch fire hose attack system. Back in the 1970s, the fire service had 3 basic hose size options: booster line, 1.5 inch, and 2.5 inch attack lines. Also back in that time, we knew that the fire environment was changing. We saw synthetics coming on the horizon, and of course they were making for hotter fires, smokier, more dense, more toxic, and so forth. Many fire departments left the 1.5 inch hose in favor of 1.75 inch hose. 2-inch was on the horizon also, and we saw the 2-inch gaining popularity in the early 80s. And the 2-inch hose was never meant to replace 2.5 inch hose, but it was actually turned out to be an intermediate size hose line. And you can see right here, this 2-inch hose is outfitted with 1.5 inch couplings. Here's 2-inch hose right here with 2.5 inch couplings, okay? This is something that happens when you have a new product on the market. Sometimes there's innovations where other fire departments like to see something like this. Some fire departments say, this is fine. I want to make a point about the 1.5 inch couplings right here. We're going to take a look at it. If you take a look at that 1.5 inch coupling right there, you can also see inside the hose, and you can see it's like a polymer type lining. This lining in here allows for greater volume at reduced friction. So it allows us to give our firefighters a stream that is higher in volume and less of a reaction force, less weight, and so forth. And to match it up with the nozzle, okay? This is a 1 1/16 inch nozzle right here, okay? Old hydraulics formulas, old hydraulics rules would say that a solid tip should never exceed 50% of the hose's diameter. Well, this is 1 1/16 on a 2-inch line. And we're seeing now, again, with the materials used in the construction of the hose, with those greater flows, now we have an 1 3/8 waterway coupled with a 1 1/16 inch tip, and we're able to get substantial flows. And we've seen flows consistently in the 240 to 260 gallon per minute range. And that's a bigger bang for the buck, especially for many fire departments where they're concerned about what their gallon per minute output is for the number of firefighters that they may have responding on an engine. One of the things about the 2-inch hose, when it came into the fire service, and I know I got my experience with the 2-inch hose started back in the early 80s, there was a lot of promises made that the 2-inch hose was going to be replacing 2.5 inch hose. And I think one of the problems that the fire service had was that we didn't have the technology of flow meters available readily to test that theory out. If the 2-inch hose really could flow more than a 2.5 at lesser weight and lesser size and so forth. But a lot of fire departments did go with 2-inch hose, and unfortunately they did away with their 2.5 inch hose back then in favor of 2-inch hose with automatic nozzles. And I think the consensus over time has been the 2-inch hose with an automatic nozzle is not a good fit. I think what happened in a lot of cases, people did not understand that if you're going to go to 2-inch hose and you have a variable flow nozzle as the automatic nozzle is, and it has a variable range per the manufacturer, but some nozzles had a 50 to 350 gallon minute flow range. To push 250 or 260 gallons a minute or more through a 2-inch hose with a 100 PSI nozzle may require a lot more pressure at the pump to get that volume of water through the hose. What happened in a lot of cases is that the back pressure was sometimes very high. And instead of pumping at the right pressure and getting that volume of water that we thought we were getting, the pressure was dialed back at the pump. And of course, the way an automatic nozzle works is that the stream looked good, but the volume of water was not what we thought it was. So as time goes on, many fire departments looked at things, had flow meters because they became available, and as we started realizing the flows, 1.75 to 2 inch, what's the difference and so forth. In many cases, the 2 inch line was flowing what an 1.75 line could flow. So the question was, well then why do we have this hose line when we can get the same flow from the 1.75 line? So we had to do our nozzle research, and that's where nozzles like this, your low pressure, high volume nozzles. As we mentioned before, this is a solid bore nozzle right here. There's different tip sizes. Different tip sizes at the predetermined operating pressure for a solid tip is 50 PSI. So this is the 1 1/16. You can look at 1 inch tips or 1 1/8 inch tips to go on here also. This hose here, coupled with a low pressure, high volume nozzle, fantastic for firefighters or fire department that want to get in there, move around and so forth. I was talking earlier about the materials used in the construction of the outer jacket. Back then in the early 80s when we had this hose, you had rubber liners and you had double jackets that were made of materials that required a bigger radius to bend. Unfortunately, sometimes this hose got pulled into a residential structure that had tight areas and so forth, and with only 2 firefighters working it, or in some cases, only 1 firefighter would work it. And the thinking was, because it had 1.5 inch couplings, and it was only 1/4 inch bigger diameter than 1.75 inches, that 1 firefighter, he could hold this line, right? And it really didn't work out as planned. Over time, with the new materials and so forth that go into the manufacture of these hoses, we've realized it's a great intermediate size line. It has higher volume, and now it has that bend radius that we can go even tighter on that. So it does have the capabilities and so forth. So, but never should this line have been talked about as replacing 2.5.